So we're live. Hello everyone, welcome to another virtual session. You are watching YouTube live. We are Java User Group Bangladesh. I'm Bozlur, your host. I'm from Dhaka. Where are you from? Let us know in the comment section. You are watching in the YouTube. There is a chat box site. So comment there and let us know where are you from. Today we have a special guest, Andres Almiray, joining us from all the way Switzerland. Hey man, how are you doing?
Hi, Paslu. How are you? Thank you for having me. This is such a great opportunity to share information with you and your audience.
Okay, great. I'm happy to have you. What is the temperature over there? Is it good?
Well, we're starting winter, so today was about 4 degrees centigrade and it's getting lower.
Oh, I see. So winter is coming.
Winter is definitely coming.
Okay, so all right. Those who already joined us earlier, you already know we do this sort of meetup virtually bi-weekly and talk about Java. Well, not just about Java, we talk about various topics. Let me rephrase that. We talk about things related to software development. Okay, so in software development, testing is one of the most important thing. Things. There are many ways to test code, right? So while we write our production code, we write test code as well to validate the production code. And test code and production code are equally important. As we write mostly Java code, Andres will show us how to test Java code effectively. So before going to this session, let me introduce Andres first. Okay, he is a Java champion. He is a Java and Groovy developer. He has more than 20 years of experience in software development. He's a Java Rockstar, Oracle developer champion, spec lead. He has an associateship in JCP. He is an author. He has many softwares that is open sourced. I'm sure he has plenty of knowledge and ideas and experience that we can get benefited from. So without further ado, let me give it to our Andres. Andres, shall we?
Thank you very much for that introduction, Baslu. Pretty deeply humbled by that. So as Baslu mentioned, when we're writing code, where we mostly concentrate on getting to production as fast as we can and trying to have a very good quality. And from time to time, we neglect testing code for various reasons. So the idea of the talk for today is to show you different techniques and libraries and projects that should help you keep writing tests in a timely manner, in a way that you find them fun and exciting, so that you don't miss writing such test cases. Now, the things that we're going to see today, you can use them for any kind of testing environment. You can use it for unit testing, integration testing, functional testing, or something else. Now, of course, everything that we're going to see today is related to Java, although if you happen to work with other languages or other platforms, it will not be the case that you will be able to use the same tools, but perhaps some of the ideas you see today might help you to find or search for something that may be familiar in that other platform. All right, so now let's get properly started. Everything that we're going to see today is open source. The tools are open source. The source code that I'm going to show is also open source. So this means that you can use it directly on your projects, whether they're open source or commercial, as long as you abide to the terms of the license. Many of these open source projects use a very permissive license that there shouldn't be any problem for you to put them into work with commercial aspects. My goal at the end of the session is that some of you will feel like this, and that you might discover a new tool, a new library, or maybe you know some of the things that we're going to see today, but you might discover a new feature or another way to make use of this particular project that you already know. Let me know in the comments if that was the case. So, well, I'm going to skip this one. Well, my name is Andres Almiray. I come from Mexico, living in Switzerland, and I love working with open source. So the code that we're going to see today is available at this URL. It's a collection of different projects that I built as time has passed by. And these are examples, are concise pieces of code that should help you, or that actually illustrate a particular point. The application that we're mostly going to see today is one called Hello PMBC. And you will find other applications in this repository showcasing other different libraries, not just testing, but also production libraries. All right. So the first thing that we're going to do is dealing with assertions, because this is a thing that when I started writing test cases years and years ago, like many of us, when we start writing test cases, actually we don't write test cases. We write a particular piece of code, like a small application that exercises the code, and we verify things by hand, typically by just looking at the screen, or maybe we have some printouts. It will be much, much better if we can verify them automatically, and this is the reason why we have assertions. Assertions work in a way that you can verify that a value is within certain range, or it has a specific value, or is it related to something else. You can assert that something is true, false, it's within an integer range, or a collection contains certain elements. So there are many different kind of assertions that you can apply. If you are still using JUnit 4, which is the most popular library that we have in Java and also in a testing environment, then there is another library that comes bundled with it, and that one is called Hamcrest. You can use Hamcrest in a standalone mode, or you can use it directly with JUnit. So the thing that we're looking here is a simple JUnit 4 test case, and I'm looking at, actually, this is not a very valid use test case because we're missing the test annotation on the method. So there is a typo here in the slides. But let's assume that this is a proper test case. And we're testing, the class under test is our sample service. So we create an instance of that, and we invoke a method on it. The result of invoking the sayHello method is what we need to assert. And we're expecting that this method will return some kind of a string, some kind of value. And we are going to match that particular value to an expected result. So if we had the contract or the specification for the sample service, the method sayHello, it should say something like whatever input you give it, in this case the string test, you will get an output of type hello test. What is remarked in blue is the specific Hamcrest matcher that we can making use of here. I would recommend to use static imports as much as you can, so that way it's much easier to read the test cases. In this case, as you can see, assert data equal to are statically imported. Now, the advantage of Hamcrest is that it gives us also very descriptive messages. If we were to run this test case, and if there were to be a failure, then we will see a message saying we were expecting foo, or in this case, we're expecting hello test, but the actual output was actually something else. So it's a bit more than just saying one value is, but the other thing that wasn't. It's also easily extensible if the default or the default Hamcrest matchers that you find in this library are not enough for your particular needs, then you can create your own. And the last benefit is that it comes bundled with JUnit. So you get started immediately without having to add an additional dependency. Yet, the thing is that as great as Hamcrest is, there are some shortcomings. The messages are descriptive, but not descriptive enough. And that some people prefer to use, instead of using the Hamcrest as an argument or the matcher as an argument, they prefer to have a fluent interface design. So there are a couple of new other libraries that build on top of the ideas from Hamcrest and provide additional features. One of these is called AsserJ. AsserJ traces its origin to a library called FEST. This was fixed. I think the acronym stands for Fixtures for Easy Software Testing. And what this one is doing, also missing the add test annotation here. Wow, I should have fixed that one. Now in blue, we see what is the difference here. Now you see that we also have another assert that method, but this is coming from the assert.j library. And instead of passing an instance of a matcher type equal to, notice that in this case, we are appending the invocation to the is equal to method. The advantage of this is that once you have selected a particular entry point for your session, in this case, assert that, and you invoke a method, in this case, say hello, and that returns a string, then the IDE of your choice should be able to auto-suggest you which matchers you can apply. One of them, in this case, is equal to. Another could be is not equal. Another could be, if it were to be a collection, it would automatically suggest you to use the contains. Whereas if it were in the case of the Hamcrest matchers regularly, you will have to know ahead of time what kind of matching option you want to use. So the advantage of this one is that it leads to a little bit better of IDE code completion. It has a fluent interface design, and the type of messages that are outputted by assert.j are a little bit more descriptive. Now, assert.j has been around for, I think it's 5 or 6 years now, and some people inside Google found it useful, and they decided to pretty much fork the code and create a different variation of assert.j, which is known as Google Truth. Notice that this also has its own assert that method, again using import static. The code in blue looks identical to assert.j. So you may be asking, so what is the difference here? What would be the gain of using Google Truth versus assert.j? Well, one is that, again, this is kind of like a fork of assert.j, so you find almost all the features, but this is a project maintained by Googlers. So if you are a fan of Google open source code, and then this will be the project for you. Also, it has a few more features in terms of the description of the messages, and I believe it's easier to attach and define your own assertions if you use truth rather than assert.j. It doesn't matter which one of the two you pick, or even Hamcrest, as long as you have all the means that you need in order to properly assert and describe the errors for your test cases. Now, finally, there is another project out there that is inspired by actually another language. You might have heard of the Go programming language, which just turned 9 years this past November 10, I believe. And one of the many things that the Go programming language allows you to do is that it has a command line interface for many things, and one of them is testing. So testing is baked into the tool chain. And one of the things that the testing support that Go allows you to do is chain multiple assertions in just one block. Now, assert.j also has a concept called soft assertions. We've been told for years that if you write your regular unit test cases, that we should A, have as minimum assertions in a single method, and B, these assertions should be independent from one another. What's the reason? If you have too many assertions in one method, so let's say you have 10 assertions, you execute the test method, and the third assertion fails, what happens with the other 7? They don't get executed, so you have no idea what state it is. You go ahead and fix the code, run it again, and now it fails on the 6th assertion. What happens with the remaining 4? Again, they are not tested. But it would have been much better if all the 10 assertions were to be executed, if they are independently from one another, and then you will get like a shopping list report of the failures. So another example would be, you change the metaphor. So when you bring your car to the mechanic will do a full inspection of your car and come back with a report of all the things that need to be fixed. He doesn't go around and say, look into your car and say, oh, you have a busted tail light. So I'm going to go ahead and fix it, and I'm going to charge you such amount of money. Once I'm done, I'm going to pop the hood and look into the engine and see, oh, there's a problem with the carburetor. And then the process continue and until he finds everything. No, that's not how he does it. He goes and executes a full thorough review of the car and let you know what's wrong. So this is the same idea behind sub-assertions. So coming back now, here's this other project called JGO testing. The idea of JGO testing is to give you some of the capabilities that Go test, which is the command tool for the Go programming language, so that you can use these things in Java. JGO testing relies on JUnit 4. We use a JUnit rule so that it will automatically verify all the assertions until the end of an execution method. So I'll say this method is called check several things, and you can see that this we're making use of the check method on the instance of test, which is the rule that we defined earlier. And we can use handcrest matchers, or we can also pass in regular booleans, as you can see in the third assertion and the third and the fourth. So if any of these fails, it's okay. It will continue to run the other assertions until all of them have finished. And at the end, you will get a single report for all the things that were okay and the other things that were failed. Again, this is inspired by Go testing. So if you're already doing some programming with the Go programming language, then you'll find this refreshing and very similar. And this is all that I have right now for assertions. And this should get you started quickly with just doing any kind of state check or state assertions again. So let's get into JUnit 4 proper. And I know that some of you might probably have already jumped into JUnit 5. Many of the other libraries that we're going to see today rely on the fact that most have not moved already to JUnit 5. And this will be JUnit 4 compatible extensions. But some of the behavior that you see today can also be provided by extensions in JUnit 5. So I have for you a simple example. It's one of the applications that you can see in the repository. Let's say that we want to build JavaFX application, a desktop-based application that can talk to a REST-based API. The example I have chosen, the API I have chosen is the GitHub API. So I'm going to query the GitHub repositories for a particular organization. So the many things I would like to do with this application, well, it has to manage concurrency. The components should be small and reusable. We don't like verbose code, so we like to reduce the amount of verbosity. And of course, the behavior that we write should be easy to test. Now, let me jump into the command line. And let's go into, I believe it will be GitHub API version, let's go with version 5. And let's run the code. There's a README on every application, on every project that you see here that will tell you how to run the code and what to do with this. So you should see an window in the middle, and this is a JavaFX application. The moment that I write the name of repository here and I click on load, this will issue network calls in order to query all the repositories that are related to that organization, and we should get around 243, 234. Perfect. So this is working. Now I'm doing everything by hand. Now, the other thing that I can do, and this is what I would like everybody to eventually test out, is do the test, and you have to trust me here. After I click enter here, I will not be touching the keyboard. So if you see a window appearing, this is another library called TestEffects that allows me to test out desktop applications, just like you would do with web using Selenium. So everything is driven automatically by by code. So it's not me moving the cursor, it's not me clicking on the button, this is all automated. It's going very quickly, and all the test cases are green. Perfect. So this application is working as we expect. So now we go back to the slides. So in order to test out this behavior, depending on how this application is built, you will need to fake out server, because you shouldn't be testing against the real GitHub servers. We will need to fake out the UI if we want the logic to be tested completely separate from the UI. You also will need to test out the whole application as a black box, just like we saw just recently by the UI just being automatically handled by some kind of robot, some kind of automation. The API, the GitHub API is documented at this URL, and said we only care about the repositories, and say that when you look at this particular URL, it will tell you what are the inputs and the outputs that you get by invoking a simple REST call such as get orgs, some placeholder, in this case organization, will be replaced for the value of any organization. The example I showed, I used the Griffon-legacy organization. And what we get as a response is a big payload of JSON objects. Each one of them identifying a repository, and a repository can have multiple properties. It could have more than 40 properties. What we need in order to write this application, well, among many things, we will use some dependency injection. We need an HTTP client and something that on top of that, that understand the usage of REST behavior. We need some way to map a JSON objects into Java objects, because we're dealing with Java. A way to reduce the boilerplate, in this case it will be Project Lombok, and finally we have a way to handle concurrency, because the golden rule of desktop applications, which is everything that is UI related has to happen inside the UI thread, such as reading and writing properties from a widget, such as reading text or writing text to a text field. Anything that is not UI related, for example, writing to the disk, querying a database, or talking to the network, must be done outside the UI thread. So we have to have at least 2 threads in this particular trivial application. Well, I've shown the application already, and on the few test cases that we have in the code, we can parameterize these cases. And if you have used the JUnit 4 parameterization mechanism, you may have found that it's easy to get started, but it starts to get a bit difficult when you really need to do a lot of parameterization, especially when you need to parameterize more than one test method in the same test case. Because the way that JUnit 4 parameterization works is that you define fields on the test case. And there are 2 ways that you can parameterize. You can define either a constructor or use annotations. But the thing is that the test case itself captures a state, which we have these fields. And every test method you define must use these test fields in the same order, in the same cardinality. So if you happen to have 2 use cases for the same test case, and each of these use cases requires different parameterization, you're in trouble. You have to write 2 test classes. But if you use a project called JUnit params, then you can parameterize as much as you want, as many times as you need. The first thing you see here in blue is that the test case must have the run with annotation, and you use a custom runner. In this case, it's called JUnit params runner. If you never used runners before, this is how in JUnit 4 we can extend the behavior of a particular test case. There is a limitation though. You can only have a single runner attached to your test case. So if you are already parameterizing your test cases with JUnit params, you may not be able to use any other kind of custom runner for any other need. Let's say that this is enough. The next thing is that in the test method, we see 2 additional things. One is the annotation called parameters, on which we are defining values directly, but you have 2 other choices. You can give it the name of a method that will be the data provider, or you can give it the class name of another class that is going to function as a data provider. Also notice that the method takes arguments. something that we couldn't do before regular test methods. And that these arguments define both the type and the name of the thing that we're expecting. So right now you're thinking, well, this is easy given that I created an array of 2 strings, so actually 2 rows of strings, and the arguments are also type string. What happens if I need integers or booleans or some other object? Well, there is a mechanism that will allow JUnit params to do type conversion, so that shouldn't be much of a problem. The advantage of JUnit params is that you can parameterize multiple methods within the same test class and with different argument cardinality. You can even parameterize in not just different cardinality, but with different types of all the arguments. You have different data provided strategies. We just saw the one with annotating with the values directly, but you can also have the test method and the and a class. Here's another thing that we can do with test cases, mocking. Mocking came to life, I think it's a little bit more than 10 years ago. And the idea behind mocking is this. If you are doing a strict unit testing, then you should test the class on the test. In this case, it's the class sample controller. And every other collaborator that you have, and by collaborator, this will be the dependencies of the sample controller. In this case, it's model and service. These classes should be very lightweight, as lightweight as possible, because you don't want your test case to fail because one collaborator is implemented incorrectly. You want your test case to fail because the class under test is the one that is implemented incorrectly. So we have some choices. We can create very lightweight classes, but we risk the chance that we have an error in these lightweight classes. Or we use mocks, which are stand-ins for certain behavior. There are a handful of libraries out there that provide mocking solutions, but Mockito is the one I consider that to be the best of the breed. Actually, the developers of Mockito, they release very fast, almost every single week. So they keep the library up to date and with the latest features. Again, in blue, we see where things are different. They are unique to this particular framework. And so we created an proxy. This standing object of type mock of sample service, and we assign it directly to the controller. Then we define our expectations. We grab hold of the mock, the service. It appears that we're invoking the say hello method, but what we're doing is recording our expectation. We're saying if that method is invoked with the specific input value, which is one of the arguments to the method, then we return a specific result. In this case, will be the output argument of the test method. Notice that we're using parameterization for JUnit params. Then after this, we execute the class under test. We trigger its expected behavior. Then we verify it. Notice that here we're using verifications with most likely Hamcrest matchers, but also verify that the mock was invoked as many times as we said in our expectations, and that the method that we defined also was called with the right input. In this verify block, we could have said, instead of only, that we wanted to verify within 1 or 3 times, so that would still be fine. But if we were to say we want this method to be called twice or 3 times, this test case will result in an error because the class under test only calls the expected method once. There is another way for you to also specify not only how many times, but also in which order. Say that we have a little bit more complicated test case, and you have perhaps it's the same collaborator or a couple of collaborators, and you know that one of them has to be invoked before the other, and you can set your expectations exactly specifying this particular order and cardinality. Then you must make sure that in the verification step, you also verify the cardinality and the order. If that's not the case, even though the class on the test might have gave you the exact result, the internal implementation of the algorithm might be wrong. So that's why we do these kind of verifications. Basically, Mockito is a fluid DSL based on static methods. You can create standing objects of three types: stubs, mocks, and spies. The stubs are objects on which you simply define, given certain input, I will return certain output. You don't expect them to be called. Just you saying, in any case, if they are called, then here you go. And you expect them to be invoked in any particular order or in any particular number of times. You simply say, if you ever decide to call this thing, then here's an output. Mocks, on the other hand, are stricter. Once you define an expectation on a mock, then their expectations must be verified in order and in cardinality. If any of these things does not match besides the inputs, then we will get an error. And finally, we have spies. Spies are kind of special because these are standing objects that are actually based on production code. Say in the previous example that the sample service had a few more methods, and we needed the invocation of those real methods, and we only needed to fake out one of the methods provided by this contract. So we will use a spy to make sure that it invokes everything, every production method that is needed, but not just the one that we need to fake out. Why would you like to do this, or why you need to do this? This is particularly comes in handy when testing legacy code bases. And the object that you are testing, the collaborator, may be too heavyweight, and you just need to start creating test cases before to create this particular safety net of before you engage into a big refactory session. So you have to start somewhere. Don't mock out the whole thing. Just start mocking a few production methods to deliver the actual expectation, and then you start to move things around. The other reason why you would like to do this is perhaps to reach the almost unattainable 100% code coverage, especially when you need to test out exceptional cases. Depending on the code base, it may be difficult to trigger an exceptional case. So you will probably need to fake out a method to throw out an exception immediately instead of just going through the actual algorithm. Mockito allows you to mock interfaces, abstract classes, concrete classes because of spies, but also final classes. So there's a little bit of reflection going on and trickery, which is quite interesting in case that you would like to know more about bytecode. But for most of us regular developers, consuming Mockito as it is just enough. If at any time you have any questions, please let me know. So say that you're using JUnit 4 and you have using Mockito, but also make use of Google Juice as a dependency injection framework, and you would like to test out your code. You can combine all the three together in your own way, or you can use a project called Chiquito. Chiquito allows you to use the three projects together in order to test out your code. Notice that this one requires a custom runner called Chiquito runner, which means we cannot use this one alongside JUnit params, so we lose our parameterization mechanism. Well, we'll see in just a moment. Notice on the second blue line that we can do injections on the test case. There are three types of injections. You can inject fields, which is my personal preference. You can inject the controller, or you can inject on setters. The jury is out there which one of the three is better, but I think that using setters will be the least recommended way. And said I like in field injection, and some other people like construction injection. Next, if we look at the test method, it's quite familiar, quite similar to what we saw before, and in the blue line looks very much what we saw earlier in sans parameterization. So we invoke we check that the mock with the specific method, say hello, was invoked only once with a given input. What is different is what you find in the setUp-mocks method. This is a method annotated with add before, which is going to be invoked before the test method. And notice that this method takes an argument of type sample service. And the blob body of this method contains the expectations that we saw before, again, sans parameterization. So this is how Chiquito works. If you give it a binding, if you have defined a type that you want to have injected via the dependency injection container, then Chiquito will happily instantiate it given the rules and give it to you and inject it whenever you put the @inject annotation. But if you do not define a binding, then it will automatically create a mock using Mockito for you. And if this object, this collaborator, is being expected in one or more than one places, then the same mock will be injected to every place. So what you're seeing now here is that the dependency injection container is aware of Mockito, and it will do the right thing when you expect it. So now you will be able to define expectations and verify them just very easily. Then I mentioned something about parameterization. What's going to happen now? We lost our capabilities. Well, not exactly. There's another annotation that we could add here in the setUp-mocks method. It's called @all. And you can annotate as many arguments as you want, and these will be the different instances. Now, if you go into the web page of Chiquito, there is ample documentation showcasing how you can do this. I mean, this example is really quite simple. The advantage of Chiquito is that you can use the 3 projects together, JUnit 4, Google Juice, and Mockito, and you can bind pretty much multiple values to the same source type. This will be parameterization. And you can use it to parameterize any kind of test method, and you can use it just with regular JUnit 4, you can use it with Java 7, even Java 8, that's not a problem. But if you're feeling a bit adventurous and you want to expand your horizons to other programming languages, then have a look at Spock and the Groovy programming language. The behavior that we see here is exactly the same that we have seen in the past. It's just the code looks completely, well, in some cases it looks similar, but in other cases it looks completely different. Now let's see something here. Look, we have a class, the name is conventional and it would expect, but you can name it anything you want. One of the hard restrictions is that it must extend from a Spock line specification. And that test method, the name, looks a little bit weird. Not just because it uses the def type, which is kind of like, this is the same thing as dynamic type in Groovy, but because the test name is actually a string. It contains spaces. And it contains hash characters. I don't know if you know, but the JVM allows any kind of character to be used as an identifier. Java, the language, is the one that restricts the number of characters to be used as identifiers. Groovy and Spock gives you back the capability to use any character as an identifier. In this case, we can see spaces and hashes. Spock requires that you make use of specific blocks. The documentation lists all the blocks. There are like 8 of them, if I'm not mistaken. And we're using 4 blocks: given, when, then, and where. In the given block is when we set up the class on the test. This is when we wire up our collaborators. This is also where we are creating a mock. Spock can support Mockito, but it also has its own mocking support. Instead, that thing that you're looking at there, that's mock sample service. That looks like a closure. I'm missing a brace. Oh no, that's the brace there, right there. It looks like an lambda expression. This is actually a Groovy closure, which functionally equivalent, but they're implemented in different ways. In the when block is when we execute the stimuli, when we execute the behavior of the class under test. One of the advantages of Groovy is that we have something called property access, which allows you to grab values of a property or set values of a property just by using the dot operator. So controller.model.input gets actually translated into bytecode as controller get model, set input. Then we invoke the method say hello, this is the stimuli. And then we have the then block. And in the then block, we have implicit assertions. And we expect the output to be some kind of string. And we know for a fact that this is not the way that we compare strings in Java, isn't it? We should be using the equals method. But turns out that Groovy has method overloading. It supports operator overloading. So the equals equals operator is actually translated into bytecode as an invocation of the equals method. So we're fine. This is good. And finally, in the where block, we have the parameterization. This is one way to do it. We're using another series of operators. In this case, is the left shift operator. And we have collection literals. What you see in there, that's a list. That's not an array. It's a list of two strings. Also in this Groovy, you can have double quotes or single quotes for the strings. And the output variable receives also two values. So this method will be invoked 2 times, one for each row. And if you don't like this way of writing code, then you can do it this way as well. It's known as data tables. Notice that that was the only change that it did. It makes the parameterization of our test case a bit more easier to read. And finally, the names of the different invocations of our method will also use the actual values, so the values for input and output because of those hashes. And that is because we added the unroll annotation to the top. When we invoke a specification without the unroll, and with these two parameterizations, we will see just one test method being reported in our IDE, but they will actually be 2 different invocations. But if you use the unroll annotation, we will see 2 methods being reported, and the values of input and output will be replaced with the actual values for each one of the invocations. So we will be very, very descriptive. The advantage of Spock is there is a Groovy-based DSL. If you know Groovy, if you know Java, you can get very quickly started with Groovy. It's actually almost a superset of the Java syntax, almost, but not fully. You can parameterize lots of methods using different arguments cardinality. You can parameterize test methods also very easily. And it's JUnit friendly, so any other extension coming from JUnit 4 that you already know, or a few others I will see in just a moment, you can combine them with a Spock as well. You can use these extensions and rules very, very easily. Here's another testing facility that we have available to us in JUnit. When we need to test out concurrency, remember the application that I showed? At some point, we're invoking a network call in a background application, in a background thread, because it is a network call. It cannot be invoked inside the UI thread. So if we were testing now our code fully, then we have to figure out how to wait for a condition or for this background code to be done so that we can continue checking if it did the right thing or not. Now, the first thing that we do usually is to put a thread.sleep sentence in our test cases. And we put some random number that we figure out. For example, it could be 2000, that we waiting for 2 seconds, it's 2000 milliseconds. Or we might put 5000, or this is just 1000. Now, it doesn't matter which number we put. It's always going to make the test case wait for that period of time. Whether the test case reacts faster, it doesn't matter. It's always going to wait that. So it's a little bit of a waste that we're making our test cases run slower because we have no clue when the thing is going to be finished. But if we had a way to conditionally wait and then react to that condition being successful or not, that would be much better. So this is what we're seeing here in blue. This code is brought by another extension called a Waitility. And what we're saying with our Waitility here is we're going to give it a timeout of 2 seconds. So we're going to wait at most 2 seconds. If the following condition that follows next is not fulfilled within 2 seconds, the test case will be flagged as red and it will fail. But if the condition is fulfilled within those 2 seconds, and that could be 100 milliseconds or 600 or the actual 2 seconds, as much as it takes within that allotted period of time, then the test cases will continue. And it will be a matter of the then block, in this case, the assertions and the verifies, to figure out if the code did exactly what we did. So after the timeout, we see another fluent call to the until method, and this takes 2 arguments. One will be a callable that returns the state. This is the condition. We're using a method reference, but it could be anonymous in a class, so it could be a lambda expression. So it could be anything you want as long as it returns a value. And then the second argument is a handcrest matcher. What we're saying here is that this condition is we're going to query the state property of the model, and when that state happens to be ready, it has to be done within 2 seconds. If this is the case, our test case continues. If it's doesn't the case, it didn't reach that state ready within 2 seconds, then the test case fails. You may be wondering how often is this condition is going to be checked. Well, this is controlled by a static property, I believe, and by default is set to 100 milliseconds, so that it checks every so often, or it's maybe 80 milliseconds. But this is something that you can tweak in case that the resolution is too big or it may be too small, depending on your use case. Waitility can be used with Java 8 or bigger. It can be used with Groovy. You can use closures. You can use lambdas from Java 8, or you can also use Scala functions. I had to check if you can also use Kotlin functions for those people that are already jumping into Kotlin. And you can customize your conditions with any kind of handcrest matcher, where are those that are coming from the standard library or any other handcrest matcher that you have created by yourself. Okay, the final thing that we're going to check here is because we are talking to the GitHub API, we need to talk to a server. And it will be a bit silly to talk to the real server every time that we're running test cases, because we don't know what is the current state of the GitHub server. Also, they have a rate limit, so we won't be able to run all our test cases every single time. The network might be down, so the server will not be reachable. So you may be thinking, oh, what about if we fake out the API? And let's create our own server. Well, what if we have bugs in our implementation? Say that you create this server. When should we run? Should we run outside of the build, so always available there locally? Should we run as part of the build? Should we run before the test case? So my suggestion is to run it as close as you can to the test cases. In this case, we have a project called WireMock. WireMock can be used as standalone to record and replay, but also can be used internally inside a test case as a JUnit rule. If you do so, then you have a very basic fake server running within your test case, and you can define expectations. So the code that we're looking here in the slide is we're refining 2 expectations. We can see, and I didn't put everything will happen even in blue, but we can see the method called stub4. So we're going to create an expectation for a get call on an URL equal to certain pattern. And if that matches, then we're going to return a response of 200, which means we found the content, and we're going to pass in some headers to the result. And this repository is a JSON block object method is actually some part of the actual test case that you see in the repository that translates a bunch of Java objects into JSON. Then we have another stub. This is for the pagination behavior that the GitHub API has. When there's another get call that matches a specific URL, then we're going to reply with 200, another JSON reply, and another set of objects being translated from Java to JSON. And that will be it. This is everything that you need to do in order to set up a fake server with expectations. So what happens when your test case doesn't, you have defined these 2 expectations, only one of them was executed? Well, it will tell you, well, I was expecting one and the other didn't came, so something happened wrong there. Or another URL came to this server that was not registered as an expectation, that will also be flagged as an error because somebody was talking to the server out of sync, out of time, or there was something that was missing. You can supply any kind of HTTP response. You can, I mean, it's up to you. You want to return XML, JSON, or any other kind of payload. It's pretty much Wiremock is a DSL for matching HTTP requests, and you can also run it for record and playback, which is quite useful when you really need to fake out a server but you don't have any network. So you can store all the static context and then content and then serve it again. So this is quite interesting. Let's continue forward, and I think that I only have like 10 more minutes to go, and so I'm going to do it fast in case there are any questions. And I expect most people to be working on the web environment, and there are many ways to write web applications. You can use Java EE, you can use Spring, or you can use something else. Say that you wrote an application without using one of these major libraries such as Spring or Java EE, and you need to test it somehow. Let's say that we create a to-do application, which you will find in the repository. There are two versions, one that uses Apache Spark as the base implementation, and the other uses Java EE. Why didn't they use Spring? Because there are so many examples out there to build Spring Boot and to test a Spring Boot that there wasn't the point of showing that. The point is to show other things. So for this application, what we use dependency injection, we use JSON mapping, we need a way to reduce the boilerplate code, so we use Project Lombok, and we need to handle persistence. So whether it's JPA or straight JDBC, and when you talk to a relational database or NoSQL database, it's up to you. But eventually we need some sort of persistence. Once you have built the application, you need to test out the server using a fake client. And for that, I would suggest to have a look at RestAssure. RestAssure is also another DSL. And you see the entry point of this method is the given block. We will connect to an application. In this case, the test case is running on port 4567. And then we can raise our expectations using those familias given when then blocks from behavior-driven development. So given that we connect to certain port, when we navigate to certain URL, then we expect the return to contain certain graph objects. Now here we're defining an object path. You're familiar with XML. You probably have heard of XML path, which is a language that allows you to navigate a graph of XML tags. Well, think of this thing that we're looking at here, todos.description, as a way to navigate an object graph. And I'm not saying that this object graph is XML or JSON. It could be either, and RestAssure will still understand it. So once it finds that all the children elements description of the root object to-dos, this has to be equal to a particular list, in this case, and Javadoc, which is the default that I have for this test case. You can validate and navigate pretty much JSON, XML, or HTML, and you can think of RestAssure as a way to create very lightweight, fake REST clients. If you are in the Java EE arena, then you know that your application needs to be packaged and run within a container. In this case, by container, I mean an application server, which makes test cases a bit more heavyweight and difficult to test. But if you use Archillian, then this will ensure that you can package the binaries, create an archive, deploy to a container, and then run the test cases within the container. You have three ways to do this. You can have the container as close as possible to the test case, similar to Wiremock. That means the container is started as shut down alongside your test case. You can have an external container that will be started and shut down by the test case. The advantage of this is that you may need additional configuration or libraries that cannot be put for some reason within the test case. And the last one is the remote. This is the most extreme one, which you have a server running somewhere independently from your test case. and you will connect to that one, deploy the test case, run it within the container, and then do the on deploy. This is, I think, this is the extremest, because you have to rely on that remote container to be running every single time that you're running the test case, which might not exactly be the case. But the advantage is that you can combine this one with rest assured in case that you need to fake out the client. And you will see this in the to-do/02 application in the repository. Now let's go with a few more and then are done. If you ever need to write PDF reports, then there is a way for you to validate that pages and content and everything you can see within the PDF is actually correct. There is this extension called PDF unit. And in blue, you can see that this one is asserting that the document has certain pages, that it has a region, that that particular thing has a specific text containing the John Doe L Limited string. If the report that you're looking at does not contain this, then there will be definitely an error. The other thing that we can see is you probably have to deal with XML, and you might need to verify that the contents are correct. There is this whole extension called XML unit. This forces you to extend from a specific test case, the XML test case. This extension was not, as far as I can tell, updated to use JUnit 4 annotations, but in any way it will still work. And this particular test case shows you that it needs to validate that some content is equal, and we're expecting this content to be read from some file, and that if you care about exact equality, even with white spaces and the order of elements within a collection, you can set it so. Or you can be a bit more lenient in case the elements in a collection may be in different order, but semantically, the two snippets of XML code are equivalent. So you might also need to test for something like that. I failed to mention DB unit. I should have. It's another way for you to set up a database in a specific state and verify that the tables and the relations have the actual data that you have without going through the existing persistent solution that you have, because that will be like self-certification. So have a look at dbunit.org. I believe that's the website, and that's another interesting library that you can check. Remember that everything that we saw today is open source. You can also contribute to open source very easily. If you find a problem with any of the libraries that we saw today, any of the code, or any other open source library in your daily work, please file a bug issue. Find the issue tracker for the project and file a ticket. Let the people at the other side know that you encounter a problem. Give them enough information on like the steps to reproduce environment as much as you can, so that they know that something is not working properly. If you have the time and the passion, the inclination, and the skills to provide a patch, then please do so. But if you don't want to engage in all the way into that, just at the very least, file a ticket. That's the easiest and the quickest way for you to keep helping others in the open source community. So with this, I thank you very much. I think I'm almost in time. And Basler, I give the mic back to you in case there are any other questions.
Oh, a lot of things. You have covered a lot. In fact, I learned a lot of new things from you. I'm sure our audience have learned a lot from your talk. Thank you very much.
Thank you, Basil.
Okay, so we have a few questions, like 5 or 7, I guess. Can you take those?
Yes, of course.
Okay, sure. So the first question asked by Shahminul Amin. He was asking about the convention of writing name. Let's say how we're going to write the unit test name. Let's say there are several conventions out there, method names, then underscore, state, under test, and expected behavior. So what do you recommend?
You definitely be as descriptive. Excuse me. Be as descriptive as you can. Regularly, the naming convention in Java is to use camel case. But as you can see, when we go back when I write functional test cases, look at that test method. it uses underscores, and it actually has numbers in the beginning, because it so happens that I run my functional test cases using an extension that runs the test methods in certain order, and the test and the state of one test method when it finishes will be the input state for the other one. So if I were to use camel case convention, it would look weird and it wouldn't read very well. And I will still have to use some kind of numbers at the beginning. So the underscore will still have to be the first character. Some other, and this is, I guess, has to do with your team members. Everybody in the team has to agree on a convention. If it's okay to use a snake cake convention like this one I'm showing here in your test cases, then let's go with that one. If all the team members prefer to use camel case, also go with that one. Another thing that I do is mix them together. The beginning of the test method says it uses camel case convention to say something, verifying behavior X, something like this. I know it sounds very, very generic. And then use an underscore, and the next word or series of words, also in camel case, will be a more specific test cases with parameters set to X, or with such parameter, or with other parameter. And if I have multiple parameters and I'm combining like a matrix, and whether this is parameterization or not, then I will also separate each one of these parameterizations using an underscore. But this is a personal feeling.
Okay, thank you. So let's take another one. Asif Hussain asked a question about, let's say we're doing a project. It has a model. It has several layers for a model service controller and the UI. So if we follow the TDD, what would be the order of the test scenario? Like, we're going to start with model first, then service, then controller, or do we have any specific order?
Not really. Again, this will be, it will sound perhaps, I don't know, you will say it's silly, but the experience will tell you where to go. And so the problem is, where do you start if you don't have the experience, right?
Right.
Just pick any layer, because if you're doing proper TDD, that means that you have to fake out the other collaborators as you go. So say that you start with a controller, which is the one that needs to consume model as service. So you create a controller test case and you figure out, oh, I need 2 services, but I don't have them. So what do I do? Well, you create those 2 classes that will contain no content whatsoever. You continue writing the test case. Now you figure out that you need a couple of methods on the services. So you define the methods and return null or empty values, because you are not supposed to implement the code yet. And then see the test fail. You have to be really, really sure that you see the test fail for the first time. You never see the test fail once, you might not be doing the right thing. So make sure that you have a red test case before you do anything else. And once you do, you start to fill out the rest of the code. My personal feeling is to start building from the innermost layer when it's clear to me what that layer is supposed to be doing. But if it's not clear, and the only thing that you have is high-level requirements, then you should start at the outermost layer. Because in this way, you can figure out if these use cases given by the business analyst and the information coming from the client actually covers where they're supposed to be going. Because if you go too deep, and as the moment that you start going up in the layers, you might end up with code that is not fulfilling the actual use case that the client is expecting.
All right. Thank you. I'm sure our audience understood what you have just said. Thank you very much. And we have another question. Actually, it's related to microservice environment. It's the person asked, named Sajjad. He said, let's say one microservice communicate with 2 other microservices to complete a task. The microservices are communication with each other over HTTP. What is your recommendation about how this kind of scenario should be tested effectively?
If these microservices are implemented using Spring Boot, I believe there is already ample documentation in that regard on how to test it. But even if it were not, well, actually, no, even if they were, and or you're using any other library, I would recommend you to have a look at another library called test containers and a technology called OpenAPI. OpenAPI is a way for you to define contracts within two collaborators. In this case, it will be two microservices. So you can see clearly what will be the inputs and outputs. And test containers allows you to run your microservice, the dependent microservice. No, not the dependent, the collaborator microservice. You can run it on a separate container with all its dependencies, such as database, security, anything that is needed for that thing to run as a black box. And you configure the test container within your test case so that at the beginning of the execution, there's nothing that is built. Then the container, in this case, Docker, will be automatically created. All the dependencies and the whatever these microservices requires will be put in place. Then the microservices are started, and because all these things have to have some period of initialization, test containers make sure that the initialization period is or the phase happens correctly. And once this microservice that you need to talk to is fully configured, is fully running, then the test case is executed. Your first microservice is the one you're testing will be fully tested. Well, that's our expectation. And when the test case finishes, whereas with success or error, then test containers will make sure that the Docker container that was initialized will be shut down properly. So this makes very, very easy for you to test out your microservices using a black box approach for the other dependent microservices.
All right, so let's take a few more. Is that okay?
Yes.
Okay. So I have a really, in fact, good question, which is Shantanu Sarkar asked about how we can distinguish between integration test and unit test. What are the boundaries?
Within integration and unit test. Okay.
Right.
So our unit tests, so let me go back to one of these examples. This one, actually. This is the moment that you start to see mocking. This should be a trigger for you to think it's very likely that it's a unit test. A unit test is typically very, very lightweight, whether it has mocking or not. You should have just one class on the test. If it has collaborators, they are either mocked or they are very simple. In this case, the sample model class is a simple POJO with getters and setters, no other behavior. So it's okay to use a real object instead of using a fake one. And every other mocked or any other collaborator that you have in this particular test case is a fake one, even if it's the database. If you have collaborators that are real, and even if some of them are like spies, then you might start thinking that this is an integration test, especially when you start to talk to collaborators that live within different layers. So you have the UI and the logic and the persistence, all of them together, and maybe you fake out a little bit of the persistence. You are setting up the state for the database, and this definitely will qualify as an integration test. But in the spirit of being full disclosure here, it doesn't matter really much if you call something a unit test or an integration test. What is important is that we write tests. It doesn't matter if you want to, or you need to qualify to one or the other. As long as the test case is giving you a report on the behavior, then everything is fine. If you don't have a test, it doesn't matter if it's a unit test or an integration test. You must have some kind of testing.
All right. So that's how I have actually my favorite questions. That is about coverage, actually. So, what do you think? What is a reasonable code coverage for a, let's say, unit test for a particular project? I mean, do we test everything? Do we need 100% coverage for everything? I mean, for example, we have a model and model has just setter and getter. Do we have to test them as well?
Uh, this is a hard one to answer because I know there are teams that really like to go for 100% coverage, whether it makes sense or not, and there are other teams that are fine with just having 60% or 80%. The number that you aim for, it depends a lot on the specific requirements you have, or in the on the current weather, if I say so. Why? There are people that will tell you that you can attain 100% code coverage if you do proper TDD. But guess what? There are only a handful of people in the whole planet that do proper TDD. So there's no way you're going to get 100% if you do that. So don't even bother. The 100% number is a unicorn. You might waste countless hours trying to attain a number that will be very hard. Why? Because you may have started writing your code, your production code before, and then afterwards added tests, and you have a lot of production code, and so you have a lot of ground to cover. It's actually your manager will start to figure out, yeah, it's a good idea to have a number as a goal, but looking at the reports of how we're doing with our velocity, we're not writing much production code, and the deadline is getting close very fast. So we better start dumping test code just so we can finish the production code, and that will put your team in a much difficult position. So pursuing a single number just because of a number will be a bad idea. I will definitely try to avoid it. As a minimum, perhaps, you will say we have to have a minimum of 40% or 60% of code coverage. If we have less than that, then we probably don't have enough test cases.
All right. So I have a following question since we were talking about this. For production code, we actually review the code very, say, religiously. How about the unit test cases? I mean, do we have to review them as well as production code? I mean, you said earlier that production code, test code is as important as production code, but how about reviewing that? I mean,
I would say test code is as important as production code. So every guideline that you follow for reviewing production code should be applicable to test code, with one exception. We prefer our production code to be dry, and by dry we mean don't repeat yourself. So if you can remove duplication, do it in a judicious way without obscuring or obfuscating the code. In test cases, as much as we can, we would like to have dry code, but in order for test cases to also function as some sort of executable documentation, at least to the development team, you may need to do some duplication. Some repetition is still okay in your test cases. This is making your code look a little wet. Recently somebody told me what is the meaning of the wet acronym, but I just can't recall this. And of course, it's as an opposite to dry. But this goes again into the dynamics of your team. Everybody has to agree on how much, let's say, a number of duplication is warranted in the test cases, or you can do it in a case by case. There may be a test case that is so much refactor and is still readable that it's okay, and there may be next to it another test case that has a lot of duplication because it makes a lot of sense when you read it and it's easy for people to follow.
Weight economy is right every time, basically. I just checked. Okay.
Thanks, Laszlo.
Okay. So, we actually maintain production code, right, for a long time, as long as we keep this project. How about the test suite? I mean, it's also require effort, right? It's also involved cost. So
yes.
how do we balance those things?
So my personal experience that happened some years ago, and that was a really funny one, is we were writing a lot of production code and not that many test cases. So we started any test case and we tried to convince our manager to allow us to have 20% of our time writing test cases. He said, no, that's crazy. how did you spend so much time writing test cases instead of production? That the client will not allow this, but we managed to do it, and our quality went up, but it wasn't good enough. So the next iteration of the project, we said, we're going to go for 40% of time writing test cases. And again, the manager said, no, that's too much. Guess what? We made it happen. So we went a little bit against our manager's expectations, but the end result was much better, and the client and the customer was happy. So eventually the manager said, okay, I will allow it. So when the next time came and said, okay, guys, how much time do you want to spend writing test cases? We said 50%. He said, okay, let's do it. There was no more reaction. And the funny thing is that we spend more time writing test cases than production, because in the previous iteration, we had much better quality, given that we have written so many tests before. So this project allows us to write more test cases, and it lived for a couple of years. And we ended up writing more test code than production. This gave us a big safety net when we had to engage into refactorings. But there will be times when if there comes a new request that changes your architecture dramatically, or there is a new feature that perforates all the layers and you need to do a deep surgery, then the test cases will be a hindrance. So you have to decide what to do. Do you throw away those test cases? Do you spend the time to fix them, or you simply start anew with some of those test cases? And again, the specifics of the project, the deadlines, the technology, and the experience of all the team members will let you know what would be the best approach.
Okay, thank you, Andres. We have already 15 minutes over 1 hour, so I think we can stop now. Thank you very much. I cannot thank you enough. I'm sure our audience would really appreciate, and again, thank you for your effort and time. We really enjoyed your session, and we have learned a lot of things from you. Thank you again.
Thank you very much, Fazlur, from everybody else following us, and thank Fazlur and everybody else at the Bangladesh Church for making sure that this stream is publicly available to everybody. You can follow me on Twitter. That is my Twitter handle that you see on the screen. There's also my personal website, and there are a few other things that I would like to discuss and talk about and blog. So if you find this content useful, let me know. If you didn't, and you find errors, well, please let me know, and that's how I can make things better also. So thank you very much for your feedback.
So thank you, Andres, again. And for the audience, we have many upcoming sessions. So please stay tuned. Keep eye on our Facebook page and our meetup group. So future we'll have more sessions, more interesting sessions. In fact, we will even invite Andres if he has time and he wants to join us again. Well,
thank you very much.
Okay, thank you, Andres. Okay, everyone, have a good night.
Have a good night, everybody. Goodbye.